Swayam Prabha. Digital India. Educated India.
Hello and welcome. I am Abhinav Dhal from the Indian Institute of Technology, Ropar. And friends, today we are going to discuss about analysis of emotion from text. So this is the second lecture in the text analysis for emotion recognition in the affective computing series. So in the last lecture, we discussed about what is the importance of analysis of the emotion from the text. The text could be in the form of a tweet, could be a document. And then we discussed how simple organization of text in the terms of the font, the curvature of the lines which are constituting the font, essentially topography, how that affects the perception of emotion. And today, first, I'm going to discuss with you a very important building block of a text-based emotion recognition system, which is the important features. How are we going to understand the context, the linguistics? How are we going to represent the text in a tweet or a document? Later on, I'm going to discuss with you few methods which are proposed in the academic community which are predicting emotion from text. Later on, we are going to switch the gears a bit and we are going to discuss about how emotion recognition can be performed when there is a conversation happening. When two people are, let's say, conversing through text, the perception of the emotion and the understanding of the emotional state of the user, that can be very dynamic. So how the emotion changes, how the perception changes over the conversation flow. So we are going to look into that. So let's start with one of the most commonly used feature representation for text, and to link it to how we were using audio and video for emotion recognition. Recall we discussed that we can have a bag of words based representation, right? So we can represent parts of an image or parts of a speech sample as a word, and then we can create a representation. Similarly, when we are talking about your bag of words, typically what we are saying is, let's say you have a document. Now, for the sake of the example, imagine the document contains information about the different cities in India. Okay, so this one, let's say, talks about Delhi, then the second document talks about Kolkata, and then the third one talks about Chennai, and so forth, right? So we have a long list of documents. Now, the content in each document would be different. That would mean the number of words in each document will be different. Now, what we want to do in the plain vanilla bag of words representation, friends, is we want to take all the documents which are present during the training, and we want to create a large repository which contains all the words. So, all the words in my training documents. Okay. From this, we can apply a simple clustering technique like k-means. We have discussed this in facial expression based emotion recognition, and that is going to give me a dictionary which will contain the frequently occurring words. So you can say these frequently occurring words are the building block of my documents, and once I have identified these frequently occurring words, I can then have a vector representation for each document separately, which is essentially the frequency of occurrence of these important words in my document, right? So that's a vector representation. So for example, if we're talking about Delhi, then the word, for example, parliament and government, history, these might be more common within the Delhi based document as compared to, let's say, a document discussing another city which is not the state capital and is, let's say, a new city, right? So you will have a histogram, a vectorized representation. Then standard method, you can train a machine learning model and predict the emotion which, let's say, the text is conveying about a city, right? Now, as you would have figured out trends here, what we are simply doing is we are counting the number of words, the unique words in a document, and then trying to see the frequently used words across all the documents, how many times they are occurring in my current document. Now, imagine when you were talking about the input stage, the first step, wherein I said, well, you create a repository of all the words in all the documents. So we were considering the words here individually. What will that mean? So let's say a line in my document says Delhi is the capital of India. Now you treat each word here separately. Delhi is one word, is one word, these one word, and so forth, right? Now, very early on, a concept was introduced, especially for natural language processing, where we said, well, let's also have combination of words which are occurring together. Now, that is referred to as n-grams. So now, when n is equals to 1, you observe this scenario where Delhi is a separate word, is a separate word, the is a separate word, so separate entities. When you have n is equals to 2, notice what is going to happen. I am going to say in the same statement, Delhi is the capital of India. I am going to take these two consecutive words together. So Delhi is, now this is one unit. The capital, that's another unit. And of India, that's another unit. Okay. One could move a step further and say, I'm also going to now take three neighbors together as one unit, as one word. So what will that be in our example statement? When n is equals to 3, a 3-gram, a trigram, you would say Delhi is the, is one word, is one unit. And once you have established the different combinations of words and the appropriate representation for n-gram, n is equals to 2, 3, depending on the value, you can then repeat all the steps which we just discussed for bag of words, wherein now these words before k means could be a combination of sequential words, right? Each word here could be, for example, Delhi is the. Now that is one unit, one word in the bag of words sense, and one could then train the system. Why would that be useful? Simply because when, let's say, you encounter an individual unit like this where we say Delhi is the, so from the word's meaning perspective, what we understand is that after this, some information about Delhi is going to be presented, right? So here we say Delhi is the, and then for a trigram where n is equals to 3, you would have capital of India as the second unit, right? So learning the relationship between sequentially occurring words as well. So that's another way of extracting information for our final goal, which is understanding emotion from text analysis, right? Now, similar to this, you can also have another concept wherein you can say, well, I am looking at the words individually or sequential words as one unit. How about I also take into consideration the importance of a word. Okay. Now, what could be importance of a word? There are different ways to discuss and describe this. One could say, well, if we have the word Delhi being repeated in a document several times, there is a high probability that the document is discussing about Delhi, something in Delhi, something around Delhi, right? The other word is, let's say you have a word the. Now, the word the is a common word and it would be repeated across different documents. So, even if, let's say, in a vector representation of a document, I'm just going to draw a histogram here, the word the could be repeated multiple times in a document, and the other words are of similar or smaller frequency. You would find that in another document histogram, the again could be very high in value, so large frequency. So the doesn't helps me much in discriminating between the types of document, and perhaps from the context of emotion recognition, it is not helping me much in discriminating between, if let's say the perceived contents emotion from a document is class X, and then in another document the perceived emotion is class Y, because these is happening so many times, it's not really helping me much, right? So how do we take care of this situation? How simply we can encode this information within our representation of the text? So for that, friends, we have the very popularly and commonly used TF-IDF representation. Now what is that? The first part of this is the term frequency, TF. Simply that means how many times a word is appearing in a document. Now, how many times, for example, the word Delhi is occurring in a document? If that word is occurring multiple times, then it could be important. Okay. We have seen words like the and a, they happen multiple times in all the documents, right? So that could mean I cannot only depend on the term frequency. What would I need? To balance it, I would need an inverse document frequency. It's called IDF. What it does is, it tells the importance, relevance of a word. How is it doing it? Well, you say for a given word, I'm going to compute the relevance by saying how many data points do I have in terms of documents. Let's say I have n data points, simply speaking, and I'm going to divide it by the number of times this particular word term happens in some of the documents. Okay, so let's say m. The happens so many times. Now I would like to use this as a weight, okay, and so that I do not do a very harsh treatment to the words which are happening multiple times in some of the documents, I'm simply adding a logarithmic to it. So this fellow is going to give a weight essentially, if you were to understand in the importance saliency terms. So for a given term, its TF IDF value would be its term frequency multiplied by its inverse document frequency. Now Delhi may be a common keyword in some of the documents and it is repeated multiple times, so you will see a high value of TF, but it will not, let's say, be giving you a low value for IDF, so that means salience. However, the word the would have a high TF but a low IDF because it is happening all across multiple times in multiple documents. Now friends, let's look at a system proposed for our text-based emotion recognition. Now we are going to discuss a classification task. So this task proposed by Gesh and others is for classifying the perceived mood in blog posts. Now the approach of the authors was as follows. They curated a large data set of about 815,000 posts from a website called LiveJournal, and then they asked the labelers to also indicate their current mood while were writing a particular blog. They had 132 categories of mood, different keywords which the labelers they gave to their particular blogs, how they were feeling. And now let's look at the features which the authors used. The first is, which we have already discussed, looking at the bag of the words based representation. Now, what the authors also did is they added what is referred to as part of speech. Now, part of speech is essentially tagging the words in your data with them being a noun or an adjective or a verb, because the number of nouns, the number of adjectives, and the number of verbs in a particular document also gives us vital meta information about the task. Second, the authors used what is referred to as a point mutual information. Now, this is a feature which was proposed back in 99, and this point-wise mutual information simply gives us the degree of association between two terms, how much two terms are related. Now, based on your point-wise mutual information, the other feature which the authors used is the point-wise mutual information hyphen information retrieval. Now, this is a work from 2001, and this gives us the probability for PMI using search engine hits. So, you use the point-wise mutual information, and then you see what is the probability of retrieving a certain result given certain keywords based on the PMI feature, which is essentially how close are two terms, what is the degree of association. Further, they would then go forward, combine this, and then do classification. Now, we saw a paradigm shift, right? As with any machine learning system, we saw earlier support vector machines, naive Bayes kind of algorithms were used, and then deep neural networks, they kind of came back in the early 2012, 2011, which affected vision analysis, speech analysis, and the same effect was felt in text analysis as well. Now, to this end, we now are going to talk about representation learning based features. So, how representation learning based features can be used to map an input text into its emotion category. To mention one of the most popular ones which are used in the community, there is the word2vec, then an extension from word2vec called fast text, and later is the glove feature representation. So, let's look at what is word2vec. Now, friends, word2vec was proposed by Mikolov and others in 2013. Now, in this representation, the authors leveraged the ability of a network to understand the presence of certain words together. So, if you look at a statement, words which are in a sequence are related to each other. So, can we use this observation, this very simple observation, and learn the vectorized representation? Now, what that means is, we would have an autoencoder. To recall what was an autoencoder, you have a neural network where the first part is your encoder, and then the second part is a decoder. In between here, we have what is referred to as a latent representation, which is essentially nothing but a compressed representation of the input. And using this compressed representation, which we input into the decoder, we get the reconstruction of the original input. Let me call it I dash. Now, since we are talking about text and word2vec in specific, if we are inputting a series of words into my encoder, then I would like to learn the relationship between them. and I'm going to use the latent representation, which is essentially going to give to me the vectorized representation of the input words. So what we are doing is we input into our network a one hot encoding. So let's say the term is Delhi is the capital of India. Now, when you have the word Delhi under the focus, you keep the corresponding index as 1, every other word gets a 0. Now, let's say in this case of word to vec, you say Delhi is the capital of India, right? So, you could use Delhi is dash of India. Now, the word capital is linked to the country which comes afterwards, and it is linked to Delhi as well, because Delhi is the capital of India. Therefore, the authors, they said, well, let us have two types of representations, two ways of computing the representation. The first one is referred to as your continuous bag of words. Now let's see what is that. So here you have your words as the input. So we were saying Delhi is the, I'm not going to input capital here. Okay, so this word is not input. This is the input here, and later it is of India. Okay. Now these are one hot encoding vectors representation of the words. What we are saying is the network would learn the presence of this word, the representation for this word, by summating the precursor and the content which comes afterwards, the content which was before, the content which was afterwards, and that is going to give me the output for representation of capital. Another representation which was proposed in the same work is called your skipgram. Now in that you are saying, well, you should be able to predict the neighboring words, right? So if you had capital city, capital of a country, city capital of a country, right? So the words before and afterwards have a relationship with the word which is being input. So how about trying to predict the neighborhood words? And in both these independent pursuits of your continuous bag of words and your skipgrams, we are learning the representation. Okay, so this is a very powerful representation, friends, which has been extensively used in predicting the vector representation for input words. Now there have been some famous, widely used extensions of word to vec, and that I'll give an example to you is, for example, your document to vector, right? So what is the vector representation for a document? So again, that is based on the concept of word to vec. Now recall, we wanted emotions, right? So what will that mean? You take the vector representation for each word using word to vec pre-trained network, then you do the pooling as we have done discussed earlier, and then you can learn a machine learning system to predict. Now another representation which I would briefly like to mention to you is, friends, the global vector for word representation proposed in 2015. Okay, in short, popularly referred to as GLOVE. Now this is an unsupervised technique to learn the representation, and simply it is based on creating and then later learning the word to word co-occurrence matrix. So the authors created a matrix which is telling us that what is the probability of occurrence of words together. Based on that, we learn a network and we are going to get a representation which I am going to be able to use later. Now let's look at one example where this representation learning is used. So friends, we have seen bag of words. Okay, we know this term bag of words now. So from bag of words there is an extension called bag of concepts. So I don't want to input individual words or your bigrams or trigrams, that is two words together, three words together as one unit, but I want to input into my system a vector which is created from a bag of concepts, right? Now, let's look at one such work proposed by Kim and others. In this, you have the raw text data coming in. You extract the representation using word2vec. Now, that gives you, for a document, the representation for each word. What we do is, we then compute a clustering on the representation which was extracted from word2vec, and later we do this weighted scheme similar to TF IDF which we have seen, right? So we are actually looking at the importance of each word. Now notice in the plain vanilla bag of words, when you are doing vectorization of an input sample, you would increment the bin in your histogram during the vectorization by, let's say, 1 when a particular new word arrives. You have checked that word. In this case, we want the histogram to be a weighted accumulation of the content in a certain bin, right? So you are doing your TF IDF, and then you are getting a representation which you can further use for predicting the emotion. Here's another system, friends, on similar lines. Now this work by Krasalwal and others, that is deep learning for affective computing, text-based emotion recognition and decision support. So how we can use the affective states for predicting the decisions which a machine could take and also assisting the user. So what do we have here? We have set of documents as training data. We have a pre-trained network which is trained on a sentiment labeled corpus. Now let's look at the features. The authors first are extracting bag of words and word embeddings from your pre-trained network. Then you are predicting the network with the features. You are doing feature fusion here for these two, and then you are predicting the emotion. In parallel, you use the word embeddings, which we have seen how they're extracted in the earlier slides. Then you extract the feature from this transfer learning based model, concatenate, and then you have a recurrent neural network. You combine the outputs together. So you do the decision fusion, and that gives you the affective states. Now, one thing to note here, friends, I'll like to draw your attention here, is for the second part, okay, for the second part here, which is when you have the word embedding and the features from transfer learning input into a recurrent neural network. What is typically happening in your RNN? Let's say the statement again, which we have been using, right? The example, Delhi is the capital of India. Now, when you are having a RNN, what you are saying is essentially you get a feature representation for this word, you input it to the cell, and along with that you have the feature representation of the second word available to the cell. So there is a sequence which is being followed, right? So this, you could say that the sequence in which the words are arriving in my statement, I am learning that pattern in recurrent fashion, in the recurrent neural network way, right? So you have the cells, you are inputting from the prior and from the current representation. Now, this has been very commonly used in natural language processing. You know, the recurrent neural networks, your LSTMs, bi-LSTMs, and they are processing that information sequentially. Now, the community slowly has started moving to other approaches where we are saying, well, we don't need sequential approach, but how about if I was able to parallelize? And these are also referred to as your non-regressive models. And after this, I will show you a few examples of that as well. Okay. Now, let's look again at another system proposed by Schalk and others, which is using social media data as input to predict the emotion from the social media post. Now, notice in social media post, you are not only going to have the text, you could also have emoticons. So in this very interesting work, the authors are first pre-processing the input text from social media post. These are the different platforms from which they are fetching the information. You see they are doing the tokenization, that is word level in individual unit creation. They are removing the punctuations, they are removing the stop word, doing the stop word removal, removing URLs, and also doing lemmaization. Now, for the emoticons, they are also adding labels to it as well. For example, they say, well, you see the joy emoticon, let's say, the representation for that is a 1. And for the text, they are actually using another mood analysis system. It's called the DPEC mood and emotion analysis. So they combine it, extract features from the emoticons, from the text, and then they are doing a machine learning based ranking. They rank the presence of the emoticons along with the text and then input that into a deep neural network to predict what is the emotion which is perceived from, let's say, a post on Facebook or on Twitter and so forth. Now let's look at another work, friends. In this work, the authors Bata Batar and others, they proposed a work called Semantic Emotion Neural Network for emotion recognition from text. What do we have in this work? We have the input words. We are extracting two types of embeddings from this work. The first is we have a pre-trained semantic encoder. It takes one word as an input at a time and gives you the representation, which is relating to the semantic information. In parallel, the same word is input into an encoder, which is giving us a representation which has the emotion representation. For the earlier one, there is a recurrent neural network and we get the fully connected layer. In the emotion channel, we are using a CNN based representation. We fuse it, get the hidden network, and then we are fusing this, concatenating. So what is happening here? We are getting your feature fusion, and then we are predicting the emotion class. So what did we achieve here? We had a semantic pre-trained representation, we had an emotion representation, and then we are fusing it together. Now, as I was referring to you earlier about these non-regressive techniques coming, right, where we could input the data in parallel. After word-to-vec type of representations, the community has moved to attention-based systems. Now, attention is simply saying an input statement comes in, what is important, what is not so important. And how do you learn that? Well, there is a whole mechanism, and I'm writing it here for you to check out separately. So there is a paper called Attention is All You Need. This is a seminal work proposed in 2017. It discusses how attention can be applied to a network for a text task, particularly in this. And this has given birth to neural networks which are referred to as transformers. Now these are non-regressive methods, that is, the tokens which are input into it, the words which are input into it are parallel taken care of. And similar to word-to-vec, the transformer-based representation, which is extremely common now in natural language processing, and hence for natural language processing based emotion prediction, is called BERT. So this is your bidirectional encoder representation, which is based on a transformer architecture. So here is a work by Huang and others. What they're doing here is they are modeling the utterances. Okay, so they are doing utterance pre-processing and they are looking at the personality tokenization. So this is the pre-processing part. They input it into a pre-trained BERT model, which is called a friend BERT, and then the second one from the emotion corpora, they are input into a chat BERT. So these are, of course, as the name suggests, have been trained on different types of data. The representation which they get, they are actually using that to do a pre-training on the input data, and they are using a masked language model and a next sentence prediction, what would come afterwards. And for the output coming from the chat BERT, they are using it for a emotion pre-training for the Twitter data. Later they do fine tuning and then they are doing the evaluation. Okay, so you can use these BERT based representation nowadays as well. Now here's another work. So this is again by Kumar and others. It's called a BERT based dual channel explainable text emotion recognition system. Okay, now notice it is explainable. Okay, now you have the input representation for each word. So these are the tokens which you are inputting into your BERT module. You get the feature embeddings from the BERT module. What do we have later? We have a RNN CNN model and a CNN RNN model. This is just to exploit the temporal relationship. We concatenate the feature output, and then we have a classifier. Now this classifier is telling us one of these four states: anger, happy, uh, hate or sad. Further, the authors also propose an explainability module, which is looking at the intercluster distance of the outputs to explain why we have anger or happy as a particular label which is predicted. So notice how the transition has happened for text-based emotion recognition systems. In the beginning, we were using bag of words, bag of concepts-based representation, and now we are in 2023. We are using systems such as BERT, which are based on transformers. Now, let's change the conversation a bit, friends. We have been talking about emotion recognition in text when the text is coming from, let's say, a blog, a document, a tweet, or a post on social media. There's another dimension, rather very important dimension to emotion analysis, that is during conversations. Conversation could be between two humans, so a human-human conversation. It could be a human-machine conversation. It could be human-machines conversation, or humans and machines conversation. So as the conversation happen, the emotion changes, the intensity changes. Now what we have here on the screen is an example from Pori and others. Okay, what you see is a dialogue between two characters. This is coming from a very popular sitcom. When what you see as the dialogue proceeds, so here is the time axis, you would notice that the subject is showing different emotions, right? Here, this fellow Chandler is showing joy, then there's a neutral, then there's a surprise after, then input coming from this person. So this, he said something, then this guy Joey says something, now emotion is elicited, and this is actually showing surprise for Chandler and so forth. So you see how for both the subjects the emotion based on the text that is varying here, right? So that means for emotion recognition, when conversation is happening, we would require a more dynamic approach. We would require an approach which would be utilizing what the other person said and what the user under focus replied back, right? And you could use the time series information as well to get the context, the long-term context. Now here is an example of a work where emotion recognition is performed during a conversation. This work by Hugh and others is titled as Dialogue CRN, the Contextual Reasoning Networks for Emotion Recognition During Conversations. What we have, friends, here is the timeline and the input conversation between individuals. What we are doing is we are extracting the feature representations which are getting us the situation level context and also the speaker level context. Again, these are the feature representations. Then the authors, they are proposing a utterance module. This is extracting the situation in which the conversation is happening. Again, these are the neural networks. In parallel, we are analyzing the speaker level cue as well, that is individually what a person said. This information is fused, then there's a classifier to predict what is the emotion during a conversation, right? So two takeaways from this: analyze the situation, analyze the content which a particular current person is speaking. Situation is going to vary based on how the conversation is happening, and the conversation is also going to be affected by the situation and the context where a person is, what are they speaking, and so forth. Now here's another work by Ye and others. This work is an interaction aware network for speech emission recognition in spoken dialogues. All right. Now in this, what do you see here? Some conversation text which is there over time. So you are extracting the utterances. Here you have a GRU, your recurrent networks, and you are also adding attention. Again, this is coming from the work which I was referring to. Attention is all you need. Then you are looking at the utterances of the speakers in parallel. So you have M and F, let's say male speaker and a female speaker, and then again a bidirectional LR GRU, extracting the representation, concatenating, and then predicting the emotion. Notice how, as compared to text-based emotion recognition, the architectures are changing when there is a conversation, because one person speaks, then the other person speaks, right? So the system needs to not only analyze the content spoken by one subject at a given time, but in parallel also look at the conversation happening together as well. Here's another work, friends, Lian and others, 2019, which is called Domain Adversarial Learning for Emotion Recognition. Okay, what you have here is you have the utterances as input. Now this is text and audio which is coming in. Now you would wonder why text and audio. Well, it's possible that the conversation is happening in the voice modality. You do speech to text and you get the text which was being spoken. Okay, now notice how for the different utterances the conversation is being mapped for its dynamic through a GRU. Then you are adding again a attention layer, and what we are doing is at different times we are predicting the emotion and the speaker level who was speaking, emotion and speaker level, and so forth. Now friends, this was a brief introduction to the very wide variety of works which have been proposed in the literature for emotion recognition during conversations. I also invite you to look at two of the survey works. Now these are very detailed survey works which are looking at the different aspects of affect prediction using text, if you are interested in going deeper into this area. So friends, with this we come to the end of the today's lecture. We discussed about the different features which have been proposed in the literature for analyzing the text, which is essentially to create a vector representation. We started with the bag of words based representation. We talked about what is n-gram. Then we looked at what is the concept of the TF-IDF, and later on how we can have a bag of concept. From this we moved on to that how with the progress in deep neural network we are using your representation learning in the form of pre-trained networks such as word2vec. From that the community has moved to attention based systems, wherein now we are using transformer like architectures for predicting the emotion. And in the same context we moved a bit forward when, let's say, a conversation is happening. When you see a machine and a person interacting or two human beings interacting, there is a very dynamic play of emotion which is happening. Therefore the system needs to not only understand the individual person's utterances, what a person said, but also look at how the relationship between the utterances that is being analyzed. Thank you.